welcome to Econometrics Melody. This is the 12th video on miscellaneous series in Stata. In miscellaneous series, we'll cover some of the basic general and handy topics. This will be more of a practical session. In this video, we'll see some of the examples of while loop. Our first example, we use I++ or post increment in order to increase the value of I by 1. We initialize the local variable I age 0. And after, while I is less than 3, we display this result and the value of I is increased, making use of I++ or post increment. So the value of I should range from 0 to 2. It's very obvious. And our second example is no different from the first, except we use ++I or pre-increment in order to increase the value of I. And let us see what kind of a result does it yield. And we see the same result, 0, 1 and 2, 1 and 2 for both I++ and ++I. But if we use I++ and plus II in order to evaluate a condition, we see a different result. Here we use I++. Again, the local variable I is initialized at 0, and while ++I is less than 3, we are going to display the numbers, and the numbers we get 1, 2 and 3. So the increment does not take place at this evaluating level, while it takes place in this loop or while executing the commands within this loop. So how does it work? The initial value is 0 and it evaluates the condition. Once the condition is fulfilled, the increment takes place. So for here, initial value 0, the result is 1. Then after this one goes over here and the initial value is 1 now, and once we evaluate it, it fulfills the condition. Now the increment takes place, so this value is 2 is displayed. Now 2 goes over here and this is the initial value. Now again the condition is evaluated. Once it satisfies, now the increment takes place and we get the result from 1 to 3. So once the value is 3 over here, again it goes over here and this is the initial value. Now once the initial value is 3, the condition is violated, so the loop terminates. Now let us see what happens if we use ++I in order to evaluate our condition, and let us explain it. But ++I here, plus means increase, the increment takes an immediate effect. So the initial value is 0 and here the value is increased by 1, so here it's 1. It evaluates this condition. Once it is satisfied, the value is 1 over here. This one goes to here and it increases by 1. Now 2 is less than 3, the condition is fulfilled, we get the result. Again the value is 2 now, so once 2 goes over here, it increases by 1. Now it is 3, so the condition is not satisfied, so the loop is terminated. I++, it first uses then increases, the increment takes place afterwards, while ++I, so it first increases, then after it uses that value. Now let us see an example of Collatz Conjecture, and we'll write a program for that, and we will use while loop. We are going to use a log file named Collatz, and we want to replace if such file exists, and we want to rename the session as Collatz, and let us execute this. Let us capture a program called luka and drop it. Now we are going to write a rclass program named luka rclass, and where it takes an argument or one argument, and that argument we are going to assign it to the global variable x. And let us explain this while loop, so we will understand what is Collatz Conjecture. For every x greater than 1, we are going to pass it through two conditions. So if it is even, we'll take half of it, and if it is odd, we are going to multiply it by 3 and add 1 to it. And if the value is 1 itself, we are going to terminate that command. So every number has to pass through this loop of two conditions. If it is even, we take half of it, and if it's odd, we are going to multiply it by 3 and add 1 to it. So every number, does it terminates to 1 or not? This is what we want to check basically. Let us write the command, and our command is ready, and let us check a number. This is the maximum limit of double type, so this is a very huge number, 10 to the power 307, and our program luka is going to check the Collatz conjecture for this number, and let us see. Yes, it terminates at 1. And let us now close our log file called Collatz, and let us see it in HTML format, and we will see this result. So this is our input number 8.98. This number into 10 to the power 307, a very huge number. And if the number is even, we take half of it, and if it's odd, we multiply it by 3 and add 1 to it. We repeat this process, and once this process is repeated, every number has to terminate at 1. It is actually a conjecture. So yes, now we're going to run iterations of the above mentioned program, luka. So let us capture any program by the name Collatz and drop it. And what we're going to do is we are going to write a program named Collatz. It is our class program, and it takes one argument. We are going to record the results in a log file, and for values I equals to 1 to t, we are going to specify this t, the argument that we are taking, and we are going to repeat this program called luka for all the numbers ranging from 1 to the specified number t, where t is the argument that we have specified. And let us run this command, or let us run this program, and now our program is ready. Now let us check whether the Collatz conjecture is true for all the numbers ranging from 1 to 10,000. This is a very huge number, and let the loop run once again. If we look at this display, all the numbers, they terminate at 0.1. In fact, the loop of 1 to 4 or 4 to 1 is repeated once the number comes to the point of 1. So it terminates at 1. Now let us this for any number. Let's say for 344, how long will it take to terminate? It's 4 to 1, and any random number, let us for the number it's 1721 or 41,000 or 4160. Again, it terminates at 1, and after this point the loop of 1 continued. And let us see it for any other number, a random number. What is it? And here this was for 9176. It terminates at 1, and this is for all the numbers, but the proof of it not been found. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.